next we are going to solve two integration questions that is of a good type. Good type means there are a good level of questions such that it looks scary and also it's a type of integral in which you have to use many properties as well as in sign substitution. So the first question is integral of x square minus 1 by x square plus 1 of 1 by root of 1 plus x power 4 of dx from 1 to 1 plus root 2, and that's the integral which we are having. So people, for this question, what plays a major role is the substitution. Because the substitution that I want to use here is in sign substitution, because it will make your mind blown away. So, but before using a substitution, what I'm going to do here is I'm going to do one manipulation. So, what is the manipulation is I'm going to divide your x square on both numerator and denominator. That's the first step which I'm going to do before using the substitution. Okay, before using substitution, I'm going to divide your x square on both numerator and denominator. So now, when you divide your x square on your numerator, what you will get when you divide x square on the numerator? What you will get is x square minus 1 into 1. X square minus 1 into 1 is x square minus 1. So x square minus 1 by x square is what? That is 1 minus 1 by x square. Correct now? This is what you will get, right? Now listen very carefully. In the denominator, I am going to divide your x square. So how I am going to divide it is, listen very carefully. I am going to split the x square as x into x. I hope you understand what I am trying to say here. I am having x square plus 1 into root of 1 plus x power 4. That is what I am having, right? Now I need to divide your denominator by x square. So I am going to divide the x square as, I am going to split your x square as x into x. Can't I write like this? Please see and say it. Can't I write like this? You guys just think of it. I can write like this now, and that's such a simple thing. Okay. So now what I'm going to do now is, first I'm going to divide this. That is x square plus 1 by x. X square plus 1 by x is 1 plus 1 by x. Correct now? X square plus 1 by x is 1 plus 1 by x. Now root of 1 plus x power 4 by x. That will be root of what? That will be root of 1 by x square plus x. Correct now? Think carefully and say, can't I do like that? And that is something, the type of integral that you guys will be left out. Okay, I will take another chop piece, people. So until then, see what I did here. So just I divided x square on both numerator and denominator. When I divided x square on the numerator, we get x square minus 1 by x square. There is nothing but 1 minus 1 by x square. And the denominator we did x square. What I am going to do here is, I just splitted your x square as x into s such that this x is for this x square plus 1 and this x is for root of 1 plus x power 4. So when you do this is the type of integral that you will be left out. Okay. So now I will wrap this because this is not important now. So after this, I am going to use that substitution. That substitution plays a vital role in sign substitution. Okay. So what substitution I am gonna do here is, I am going to take your 1 plus 1 by x. I am going to take here 1 plus 1 by x as t. If you take here 1 plus 1 by x as t, then your dt will be nothing but differentiation of this. Differentiation of this is what? Differentiation of this will be differentiation of 1 plus 1 by x. Correct na? But think carefully. Before going on to that, what mistake I did here is, I was dividing your x square plus 1 by x now. When you do like that, this x square by x will be x. Okay, that's a mistake I did here. Hence, I can take x plus 1 by x as t. Sorry people, I want to take x plus 1 by x as t. Okay, I hope what I am trying to say here. X square plus 1 by x is x plus 1 by x. Sorry, really sorry for that. So now when you take x plus 1 by x is t, then your dt will be 1 minus 1 by x square of dx. Correct, no? That will be your dt. And this is the substitution I am gonna apply here. Okay. So when you apply this substitution, how this integral will change is 1 minus 1 by x square of dx will be dt numerator, then divided by x plus 1 by x is what? T into root of 1 by x square, root of 1 by x square plus x square. Root of 1 by x square plus x square, this is what you will be left out. So now when you take the substitution, what I will get here is, listen very carefully, I can write this 1 by x square plus x square as t square minus 2. Can't I write like this? Think carefully and say, people, because what the thing I'm doing here is I'm just using the substitution in the integral, and that's the easy part that you guys are already familiar with, right? So that's what I'm doing. So when I take your x plus 1 by x as t, then dt will be this expression. Hence, in the numerator will be 1 minus 1 by x square of dx, that is your dt, and denominator having x plus 1 by x, that is your t, into root of 1 by x square plus x square will be t square minus 2. I will explain how it is. What will be your t square? T square will be x plus 1 by x whole square. X plus 1 by x whole square is x square plus 1 by x square plus 2 times of ab. 2 times of a, 2 times of x into 1 by x, that is 2 only. Now when you subtract 2 from your t square, I will get minus 2. Hence this plus 2 minus 2 will get cancelled, and finally I am getting your 1 by x square plus x square. And that is why I am writing this expression as t square minus 2. I hope that makes you people clear. I hope that makes you people clear. Just using substitution here. So now after this, what you are gonna do is, you just need to change the limits. Don't directly write the limits as 1 to 1 plus root 2. Never ever do that mistake. The limits must change depending upon the substitution value of t. So how will you change the value of t? How will you change the value of the limit is, here the limits will take upon the value of t. Never forget that. The limit will take upon the value of the variable that you are putting. So how will you change that? Listen, when you consider your lower limit, I am having 1, right? When you consider your 1, put your x as 1, then you will get 1 plus 1 by 1, that is your 2. Hence your t is 2 for your lower limit, so I can write this 2. Okay? I hope that makes you people clear. Now, when you consider your upper limit, I am having 1 plus root 2. So now, put this 1 plus root 2 in place of x, so that I will get 1 plus root 2 plus 1 by 1 plus root 2, and that will give us 2 root 2, and that will be your value of t for your upper limit. And that is how you will change the limits. And now after this is a very easy task. Okay, after this substitution and changing limits, it's going to be very easy question. So I will repeat once again. When you answer lower limit, put 1 as x, so you get 1 plus 1 by 1, that is 1 plus 1, that is your 2. So value of t for lower limit is 2. And the value of t for upper limit will be 1 plus root 2 plus 1 plus 1 by root 2, that will be 2 root 2. Just solve it up. Okay, just solve it up. And then you will get 2 root 2. So now after this, what you are going to do here is, I am going to write this 2 as root 2 square. I can write like this, very simple. I am just writing the 2 as root 2 square. What is the reason behind doing this is, because I not to use one standard integral formula. Standard integral formula, this integral of dx divided by x into root of x square minus a square is equal to 1 by a of secant inverse of x by a plus some constant. This is one of the property of your indefinite integration. So integral of dx divided by x into root of x square minus a square is 1 by a of secant of x by plus some constant, where your x is the variable of the integral and a is a constant. So when you sing these two integrals, what I will say is, your x will be t and your a will be root 2, correct now? And that is how I wrote you, and that is why I wrote your 2 as root 2 square in order to sing these two integrals. I hope that makes you people clear. So I can write the same integral as 1 by a. 1 by a will be 1 by root 2. So I can write as 1 by root 2 into secant inverse of x by a. Secant inverse of x value, secant inverse of x value by y value. What is x value? That is t here. Instead of x, I am having t here because t is the variable of this integral. And what is your a value? That is root 2. That is root 2. Now, don't put plus constant here because this is definite integration. Here I had no limit and that is why I wrote plus constant. But here I am having limit. Hence, you need to put the limits here. That is from your 2 to 2 root 2. Correct? Correct? Now it's a very simple task. First put t as 2 root 2. When I put like that, you will get 1 by root 2 into secant inverse of t by root 2. When you put 2 root 2 in place of t first, you will get 2 root 2 by root 2. 2 root 2 by root 2 is 2. Then minus of 1 by root 2 into secant inverse of when you put 2 in place of t, what you will get there? When you put 2 in place of t, what you will get is 2 by root 2. 2 by root 2 is root 2 only. Just you are rationalizing the denominator. So this is something we will get now. Okay. So now when you solve this up, take 1 by root 2 common. Then we will get it as secant inverse of 2 minus secant inverse of root 2. Secant inverse of 2 is pi by 3. Secant inverse of root 2 is pi by 4. So now when you solve, get it as 1 by root 2. You will get it as 1 by root 2 into pi by 3 minus pi by 4 will be pi by 12. Yes. So 1 by root 2 into pi by 12 will be pi by 12 root 2. And that's the answer for the question. It's a beautiful question. It's a beautiful question. Okay. And that is how you guys will approach this question. I hope you guys will enjoy the solving. Right? So finally what I did is just to use this formula. Now solve this limits. You know how to solve the limits. So hence after this secant of 2 is pi by 3, secant of root 2 is pi by 4. So 1 by root 2 into pi by 12 is pi by 12 root 2, and that's the answer for the question. Let us move on to the next one. Our next question is integral of x into sine of x square of dx divided by sine of x square by sine of log 6 minus x square from root of log 2 to root of log 3, and we are supposed to find the value of this integral. So people, how we are going to solve this question is, in this question, I am going to use your King's rule. But before going on to your King's rule, I am going to do one small substitution. Then I will go upon with your King's rule. Okay. So what the substitution I am going to do here is, I am going to take your x square as t. When you observe this integral itself, we know that I am having a sine of x square. So therefore, I need to take your x square as t. If you take your x square as t, then your dt will be nothing but differentiation of x square, that is 2x. Then of dx will be your dt. Correct now? This is substitution I am going to use in this integral. So when you take your x square as t, your dt will be differentiation of value of t. Differentiation of x square is 2x. Of dx will give us dt. So now when I apply this substitution in this integral, I can write the same integral as integral of x into sine of x square of dx. We know that your 2x of dx is dt, hence x into dx will be dt by 2. And that 2 I can take outside the integral, therefore I can write it as 1 by 2. I hope you guys could understand what I am trying to convey to you people. As we are having x into sine of x square of dx, we know that your 2x of dx is dt. If 2x of dx is dt, then x dx will be dt by 2. Correct now? Common sense. So hence dt by 2, I just took that 1 by 2 outside. Then what I am having is dt into sine of x square. Sine of x square will be sine of t. Correct now? Sine of x square will be sine of t. Because I am having sine of x square, so sine of x will be sine of t. Then divided by what I am going to have in your denominator is, as your x square is t, then sine of x square will be sine t only. Then plus of sine of log 6 minus t. This is the type of integral that you guys will be left out. Okay. So when you take x square as t, you will dt is 2x sub dx. This is the sort of integral that you guys will be left out. Okay. So now let me take this integral as IE. Let me take this integral as IE. So I is equal to 1 by 2 into integral of sine t of dt divided by sine t plus sine of log 6 minus t. But what will be the limits here? I took this as IE, no problem in that. But what will be the limits? If you know the limits only, you can use the King's rule. But now I know that you guys will do one silly mistake. You will directly write the lower limit as root of log 2 and your upper limit as root of log 3 because it is something is given in the question. So you should write the same limits. This is the common mistake which everyone do. Never ever commit this. Whenever if you use substitution, you are supposed to change the limits, and that is very important. You can't write the same limits. Okay. So how will you change the limits? It's very simple. When you consider the lower limit, I am having root of log 2. Put this value of root of log 2 in place of x. Then you get root of log 2 square. Root of log 2 square is log 2 and d. So hence the value of t is log 2 for your lower limit. Now when I consider the upper limit having root of log 3. Put this value of root of log 3 in place of x so that I will get root of log 3 whole square. That is log 3. Hence the value of t is log 3 for your upper limit. And this is the method by which you guys will change the limits. Very important. Never ever commit a mistake. So now I am going to use your King's rule. So what your King's rule says is very famous one, guys. If you don't know this, then I think you guys are not aware of the syllabus. So integral f of x dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. This is what your King's rule says. So integral of f of x dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. A to b, the limits won't change. The limits will be same. For substitution only, your limits will change. For in King's rule, your limits won't change. It's a famous property and you guys are supposed to know. Okay. So when I take this integral as I, using a King's rule, I can write the same as integral of f of a plus b minus x. What is f of a plus b minus x? F of lower limit plus upper limit minus x. So f of lower limit plus upper limit minus x will be nothing but f of lower limit is log 2. Correct? It is log 2 plus log 3 because your upper limit is log 3. Hence your b is log 3 then minus x. So people, the difference between these two integrals is the variable is t here, but the variable of the integral is x. The variable of this integral is t, but here the variable of integral is x. No problem in that. So hence I can replace this x as t. I hope you know what's the reason in that. Because here the variable of integral is t, but the variable of integral is x. That is why I just converted that x as t in order to sing this integral, in order to make it up of that form. Okay, I hope that makes you people clear. So I can write the same integral as 1 by 2 into, the limits will be same only. When you use King's rule, limits are same, right? C, a to b only. So log 2 to log 3. Now now what will be your numerator? Your numerator is sine of t. When I use King's rule, I need to write the instead expression as f of a plus b minus x is f of a plus b minus x. Hence f of a plus b minus x will be f of log 2 plus log 3 minus x. So hence, if we need to write it as f of log 2 plus log 3 minus x, I can write this t as log 2 plus log 3 then minus 3. I hope you guys understand what I am doing here. Then of dt, then divided by the denominator will have sine of t. So I need to replace this sine t as what? Correct now, people? Yes. So then divided by sine of t. So same t value. So that is log 2 plus log 3 minus 3. Then what I am having is sine of plus sine of log 6 minus t. When I put the t as log 2 plus log 3 minus t, what you will get is, what you will get, people? Think well and say. When you put 6 minus t, I am having na. Okay. So what you will get is, I will be left out with log of, listen, I am having log of 6. 6 will be 6 only. Then minus of, I should write this t as log 2 plus log 3 minus t. This is how I will write it up. This is a new form of integral that you guys will be left out when you use the King's rule. So now after this, guys, I will repeat once again. If I need to use King's rule, I should write it as f of a plus b minus x. So f of log 2 plus log 3 minus x is something I wrote here. Here I am not having x because the variable of this integral is t. And that's the basic concept. I hope you guys know that earlier. So now let me rub these things. So I can write the same I as. Listen. 1 by 2 into integral log 2 to log 3. Listen very carefully. Not log to the base 2. It's log 2 to log 3. I am having sine of log 2 plus log 3 minus t. What is sine of log 2 plus log 3? Log properties. As I am having sum, you can multiply the inside expression. Okay, so 2 into 3 is 6. So hence it will be sine of log of 6 minus t of dt. Correcta? Then divided by sine of, here also I am having same expression, log 2 plus log 3 will be log of 6. Log properties, log of 6 minus t. Then plus of sine of log 6 minus log 2 plus log 3 minus t. So here you will have log 6 minus t. Correct na? Log 2 plus log 3 is log of 2 into 3 is log 6 minus t. So minus of log 6 minus t will be minus log 6 plus t. So log 6 minus log 6 will get cancelled. So finally I will be left out with plus t. Hence that is sin t. I hope you understand what I am doing here, people. I am having sine of this now. So I will write here. No problem. I will write here. So sine of log of 6 minus log of 2 plus log of 3 minus t. This log of 2 plus log of 3 is log 6. Hence log 6 minus log 6 is 0. So minus into minus is plus t, and that is why I wrote it as sine of t. I hope that makes you people clear. So now after this I need to add these two integrals. And with that the work is over. And with that the job is done. Okay. So when you add these two integrals, what you will get is I plus I will be 2i. 2y is equal to half into same constant. Limits also same because in King's rule the limits is same na. Hence the limits will be same. Not a to b. Not a to b. It is log 2. Log 2 to log 3 of, when you add these two integral expressions, you will be left out with 1 d theta. Solve it up and say, when you add these two integral expressions, as the limits is same, I can directly add the integral expression. Then you will get sin t plus sine of log 6 minus t to base sin t plus sine of log 6 minus t. So both these terms will get cancelled. Hence I will get it as 1. When you add this expression, I will be left with 1. That makes, I hope that makes you people clear. Then so I will get it as 1 by 2 into integral of 1 dt. Integral of dt is t. Right? So the limits are log 2 to log 3. So now I can write the same limit as half into, first put t as log 3, hence I'll get as log 3. Next put t as log 2, then I'll get as minus of log 2. So now if we solve it up, I'll get it as 1 by 2 into log of 3 minus log of 2. It will not be log of 6. It's subtraction here, not addition. Hence you need to divide the inside value. That will be log of 3 by 2. Log 3 minus log 2 will be basic property of logarithm. Will 1 by 2 into log of 3 by 2 be the answer? Nope. We know that your 2y is equal to 1 by 2 into log of 3 by 2. Hence your I will be 1 by 4 into log of 3a by 2. This is a beautiful question. So hence your I is equal to this value. This is 2y. But we need to find the value of I. Hence it is 1 by 4 into log of 3 by 2. That's all guys. I hope you guys will